Welcome, this is 9-2A, Common Denominators. Before we get into the notes, let's review what a least common multiple is, LCM. Okay, so consider 18, 324, and 450. What's their least common multiple? To find a least common multiple, you just start writing out multiples of each number. So 18, 36, right, 54, you just keep going. Okay, 324, if we double that, we would get 648, we would just keep going. Okay, 450, if we double that, we get 900, we would just keep going, right? So 18 goes into 324, 18 also goes into 450. So 18 and 450 have a least common multiple of 450, but this 324 is throwing us off, right? 324 does not go into 450 evenly, okay? So a shortcut to finding a least common multiple is to just multiply all three numbers together, okay? So you can take 18 times 450 times 324. This will not give you the least common multiple, but it will give you a multiple. So if nothing else works, just multiply them all together. You get a pretty big number, okay? So that's the concept of a least common multiple. This is going to be important in 9-2A, which is about common denominators. So in this unit, we're working with rational expressions, right, which are fractions, so like x plus 1 over x plus 4, 2 over x plus 5, etc., etc. We can actually add these rational expressions together, but in order to do that, we have to get a common denominator. Okay? Just like we do with fractions, right? If I want to take 2/5 plus 3/4, I can't just add yet. I have to make them have a common denominator of 20 first. Okay? So least common multiple is the least multiple that two terms have in common. Well, that any number of terms have in common. The LCD is the LCM of denominators, right? So we can use these concepts to add and subtract rational expressions and fractions. So for example, the least common multiple of x squared and 2x to the fourth, that should say is, I don't even know what I'm saying there, I'm so silly, is 2x to the fourth, right? And then the least common denominator of 1 over x squared and 1 over 2x to the fourth is 1 over 2x to the fourth. I'm going to make that switch in your notes real quick. Okay, so consider this. What would be the least common multiple of these three terms? 6xy, 15x squared, 9xy to the fourth. My first step is to look at the numbers. Look at the numbers and find their least common multiple, and then work with the variables. Okay, and then put that all together. So looking at 6, 15, and 9, we can just start writing out multiples of 6. 6, 12, 18, 24, 30, 36, 42, right? You can just keep going, keep going, keep going. 48, 54, 60, 66, 72, 78, 84, 90, all right? And then 15, we can start writing out multiples of 15. 15, 30, 45, 60, and I just suggest, guys, that you just keep doing this. Just keep writing out multiples until you feel like you have enough, and then you still might have to go back and add more. So we're looking for the least number that shows up on all three lists. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108, and then we could keep going if we desire. Right, so ask yourself, what is the smallest number that shows up on all three lists? All right, we see we have 90. 90 shows up on all three lists. None of the other numbers show up on all three lists. Okay, that's the smallest number that shows up on all three lists. So we know that our numerical portion of the LCM, the least common multiple, is going to be 90. Okay, and then now let's look at these variables. So with your variables, just look and see, look at your x's. Okay, so we have x, x squared, and x. These x's are understood to be to the first power, and so we want an x for sure, and then the exponent that we want is just the highest exponent that we see out of all of those, okay, which is 2. And then for your y, look and see we have a y to the first here, and we have a y to the fourth here. We don't have a y here, so we want to take a y, and then we want that y to have the biggest exponent. So our least common multiple of these three terms is 90x squared y to the fourth. Okay? We're going to try this one. All right, so we want to try the least common multiple of this expression and this expression. Then you have a hint. The hint is to factor each trinomial. All right, so y to the fourth plus 8, y to the third plus 15y squared. Let's try to factor that. First, we want to try to factor out our greatest common factor of y squared. And then now we want to try to factor this trinomial, all right? And it will factor into y plus 5, y plus 3. All right, and then now let's work with our other one. Y squared minus 3y minus 40. What does that factor into? You can use the AC method. You can use guess and check. We should find out that this factors into y minus 8 and y plus 5. Okay. And so now looking at this expression in factored form and this expression in factored form, we want to write their least common multiple. So we're going to take each factor and we're going to write it as many times as needed. So this y squared has an exponent of 2. This y plus 5 has an exponent of 1. You see that? This y plus 3 has an exponent of 1. This y minus 8 has an exponent of 1. This y plus 5 has an exponent of 1. So we're going to mix those together. We need a y squared. We need a y plus 5 to the first power. And because that shows up in both, and the power is 1, we just write it once. We don't have a squared up here. We just write it once. Okay, because this is the least common multiple. If we had an exponent here of 2, that would still be a common multiple, but it wouldn't be the least common multiple. Okay, and then y plus 3 to the first, we see that over here. We don't see it on the other side, so y plus 3, and then here we see y minus 8. We don't see it on this side, so we just write it once. And this is our least common multiple of those two expressions. Okay, so you may have to factor first and then go from there. All right, let's consider this one. Give it a try. 12, 15, and 8 have a least common multiple of 120. We have an a squared. We have an a to the first. We don't have an a over here, so we just need that a with the highest exponent that we see, 2. Looking at our b's. Okay, we have a b to the first, a b to the first, and then a b to the third. So we need that highest exponent, b to the third. And then we have a c to the first and a c to the fourth. So we want c raised to the power of the highest exponent, which is c to the fourth. Okay. Consider this one. Okay, we need to factor first. Factor out of 4. And then factor from there. Here, factor out an a. And then this will factor into x minus 5, x minus 4. And then now look at both expressions, right? We need a 4. I'm sorry, somehow I changed these to x's. Silly me. Okay, we need a 4. And then we see we have a minus 4 as a quantity that shows up on each. So we're just going to write it once. And then we see a plus 1 and then a minus 5. We need those as well. So this is your least common multiple there. Okay? So that's one of our skills, finding common multiples. All right, and to intro into the second part of 9.2, as we get into adding and subtracting rational expressions, this is our golden rule. Okay, we have to keep in mind that you must have a common denominator in order to add or subtract rational expressions. So like this, right? Fraction, 6 over z plus 5 minus 2 over z plus 5. Notice there's already a common denominator. Okay, so that actually makes our task really straightforward. We can just write it as a single fraction, 6 minus 2, right? And then this is our solution. Just like with fractions, if 3/5 minus 2/5, if we're trying to combine that, then our denominator is still 5. We take 3 minus 2 and we get 1. All right, so it's similar logic here. Okay? That's all I got. Try to practice this and then let me know what questions you have.